Thank you. I'm glad to be here, and I have to thank Heartland for arranging this conference. I'm going to take a much narrower look at the world than Paul did, or even Steve. I'm actually going to adopt the definition or the views of sustainability that the Greens have. And I hope to show that under those very definitions, fossil fuels have made the world much more environmentally sustainable. But before I go there, I think the single most important thing about sustainability, which many people seem to miss, is that if it is not economically sustainable, it is not sustainable, period. And subsidies don't count, because after some time you run out of everybody else's money. And as the Europeans are going to find out, and actually, from our point of view, we shouldn't try to dissuade the Europeans. They want to shoot themselves in the foot. It's your foot. You can do with it what you want. Go ahead and do it. Well, I'm sorry you're trapped in that. Okay. And in fact, I think that was one of the reasons why the Europeans were after the Americans in the 1990s and earlier for us to have climate change regulations, etc., because they saw that we had a little bit of an advantage in terms of energy development, etc., and they wanted to rein us back. They had no idea that we'd have shale, etc. At that time, nobody did, actually. Anyway, that's neither here nor there. So as I said, I hope to show that under the currently acceptable definitions of sustainable development, fossil fuels have made the environment more sustainable. And that's why I've titled my talk that fossil fuels allow the rest of nature to coexist with humanity. Before going there, let me note that it is virtually acknowledged by everybody that the single most important reason for the loss of ecosystems and biodiversity is, quote unquote, habitat loss, or I would say more accurately, most of the time it is really habitat conversion, because you don't really lose habitat if you convert something to cropland. It's still there, it's being used, maybe not as efficiently or for the things that you'd like it to be used for, but it's still being used. Anyway, that's neither here nor there. Let's continue. I'll show that fossil fuels have forestalled massive habitat conversion, substantially lowering the risk to biodiversity, even as the needs of an expanding and wealthier population are being met. So how does fossil fuel reduce habitat conversion? Well, it all comes down to the fact that it increases the productivity of the entire food and agricultural system from the farm to the consumer, and even before that, in fact, as we will see. And because of that, less habitat is converted to cropland, which means there's more land for the rest of nature, and which reduces the threats to biodiversity and ecosystems. Now, fossil fuels have managed to do this, as I said, through, I'm all thumbs, I'm sorry for that. Okay, through a whole set of fossil fuel driven technologies that have directly or indirectly increased net yields on the farm through things like the use of nitrogen fertilizer, which comes from the Haber-Bosch process, pesticides, most of which are derived from petroleum or natural gas, irrigation, which needs irrigation pumps need fossil fuel generated electricity or or directly, they use ICs, and internal combustion engines, agricultural machinery, and then we have atmospheric CO2 fertilization and atmospheric nitrogen deposition. And I should add these days, climate change. All of those are the result of direct or indirectly, for the most part, the usage of fossil fuels. At the same time, the losses at each stage in transportation, in storing, whether it's at the market, whether it's at the consumer, whether it's in between, etc., all of these use technologies that are fossil fuel derived. You cannot, your Ziploc bags and stuff like that, saran wrap, etc., they're all petroleum products. It's like that, that kayaking thing that Steve was showing. Everything there is made of hydrocarbons. Actually, I wish somebody would have a model up there, not a climate model, a real model, and let's go through an exercise where we take off each article that the person is wearing, if it contains or is based upon fossil fuels, and you'll find, hey, lo and behold, we are just like nature. Like we came on Earth from nature. Anyway, I don't think our fossil fuel people have figured out that that would be a good way to sell their products, or at least sell people on the social value of their stuff. Okay, let's move on. For example, we have a bunch of, here's one technology that predates the internal combustion engine. It actually doesn't. This was in 1938. It's a 16 horsepower combine. Okay. Well, the internal combustion engine got rid of these 16 horses, but the most important part is that in 1910, 27% of our land was devoted to raising crops, feed for animals, for not just animals, horses and mules, etc. So if and when internal combustions came in, we had 27% of the land was no longer being used for this, and that land could now be used for human food. Except, of course, we are working on destroying that by making, having people grow fuel on that. Anyway, so automatically that 27% reduction leads to an additional food for 36 or 37% people. Imagine the saving that we've got in terms of land conversion. Okay, yesterday I showed these, and to make the point that indirect CO2 fertilization, nitrogen deposition, and climate change has increased the Earth's productive since 1982 alone. Okay. Which isn't going all the way to the Industrial Revolution by 14%. So if you went back all the way, it would be a lot more. I haven't figured it out, but apparently the IPCC somewhere it's a throwaway line, and I've got to chase this down. It says that the global and biological global land biological productivity may be 5% higher now than in pre-industrial times. Think about this. We've destroyed all those forests. We've deforested a good part of Amazon, a good part of India, etc., and we are producing, the land is more productive despite that. And fossil fuels are a good part of that. So what I'm going to do now is I'm going to estimate. Okay, in any case, before, let me go through this. What this tells, I can't even figure out what I've got here because I don't read very well from the corner of my eye. Okay, we've got cropland and pasture from 1700 to the present, to 2012. Okay, and I also have it per capita. But we can see that the amount of cropland and pasture land has kind of peaked. Okay, these are the solid blue and solid red lines, and on a per capita basis we are using a lot less, and all of that has saved. You can see how much land it would have saved if we had kept on converting land at the same rate as the population was rising. Okay, and this is what fossil fuels have allowed us to do. So what I'm going to do is try to estimate how much land fossil fuels have saved for the rest of nature. Okay, I purposefully use the term rest of nature because a lot of people believe we are apart from nature. We are not. And it's very important to use those terms because people have to recognize that we are part of nature. So this dichotomy which you have in the sustainable development paradigm normally adopted, that there's the rest of nature and there is us, I don't think that's a really good breakdown, actually. And it's actually a false breakdown. So what I'll do is I will just look at a lower bound estimate, because the point I'm trying to make is that fossil fuels have made us a lot more sustainable. Okay, I don't care if what the upper bound is. And I will just look at 3 major sources of increased productivity: nitrogenous fertilizers, pesticides, and aerial fertilization from CO2 and nitrogen deposition. And this is an underestimate because I've left out lots and lots of technologies that one could have looked at. Okay, for example, I'm not taking into consideration the fact that agricultural machinery is now driven by internal combustion engines rather than horses and mules. Okay, things like that. I'm going to ignore the fact that irrigation uses fossil fuel powered pumps. Also, I'm also going to ignore the fact that all this stuff has actually made pasture lands more effective. So I'm just focusing on cropland. Okay, so when I do this, this is what I get. Okay, the other thing that we have to remember is I'm going to ignore the fact that 70% of the global fiber production is from fossil fuels, is from synthetic fibers. That is from fossil fuels. That means virtually, and only 30% from the rest. Fossil fuels account for 81% of total primary energy supply. If we were still relying on the land, biomass, etc., a lot of that 30% of fiber and 81% of energy would have to come from the land. I'm ignoring all that. So what I'm giving you is a really low bound, okay? And this is what I get. For nitrogenous fertilizers, in 2008, on the 100th anniversary of Haber-Bosch, it was estimated that 48% of food production was due to the Haber-Bosch process. Enormous amount. And if you look at synthetic pesticides, I estimate using Werke, I'm not sure how you pronounce it, Werke estimate, he looked at he looked at 7 or 8 or umpteen crops actually, and I think he must have looked at thousands of experiments essentially, and he figures that in the absence of any pesticides, there would be a loss of 50 to 77% of crops. And and that's right. And I use his estimates, and I assume that in the absence of synthetic pesticides, the other pesticides that we'd use, because farmers are still going to use pesticides, or they will use other methods, I will assume that the substitute pesticides will be 50% effective, which I think is relatively high. Okay, and then I also assume that there's a 10% increase in productivity from CO2 fertilization. And I have not bothered about the nitrogen deposition, etc. If I do all those, sum just these 3 factors, then I've figured that just because of these 3 factors, the increase in food production is 174%. That means instead of producing 100 units, we are producing 274 units. Okay? Now, this means that to make, if there were no fossil fuels, we would have to have 4.3 billion hectares rather than 1.6 billion hectares. That means we'd have to convert 21% of global land area into cropland, okay, which is about the size of South America and Europe combined. And when you compare this with all the land that has been set aside for nature by all the governments, there has been a push to do that. And by 2009, that set aside 12.5%. It's more than that. So what I'm saying is fossil fuels have saved more land for nature than all the conservationist efforts. They wouldn't like to hear that. Okay. The other thing is Barnowski and company, he's a guy who's always pushing the tipping points theory, okay? He says that 43% of global terrestrial ecosystem has already been converted to human use. So if I add the 21% to that, I get 64%, okay? Now, he says that, they talk about tipping points, but these are, nobody knows what the tipping points are. So they postulate these, and he says his tipping point would be at 50. Well, we'd already be over his 50%. He'd have to revise that number now. Okay. Now, so if we were using 64% of biological output just for feeding us, okay, what would that do to species? So I use something called the species area curve, okay, and based on that, I figure that the species at risk of extinction would increase by 70 to 78% had there been no fossil fuels. And as I said, this is a lower bound estimate. So in summary, global ecosystem productivity has increased. Fossil fuels are responsible for at least 63% of global food production, and we would need an additional 21% of global land area just to meet human needs, and we would have exceeded the so-called tipping point, and potential species extinctions would have increased by over 70%. And that's why I say fossil fuels have made it possible for human beings to coexist with the rest of nature. And that's how fossil fuels make us more sustainable, environmentally sustainable. Thank you.